All right, today we're talking about direct variation.
Choking.
Has anyone heard of that phrase before, direct variation? I wouldn't expect you to know it. I don't think you've done it yet.
Yes. Alright. You wouldn't expect us to know it? Is that what you said?
All right, so you have in your notes here this equation, y equals kx. This is what we see when we do direct variation. All right, so this value up here, k, this is my constant of variation. Constant of variation. That is my k value. It's the value that's in front of your x. Direct variation is often signaled by phrases like varies directly. So when you see the phrase varies directly, that means we're going to be using this equation here. Make sure you're writing this down.
I don't know my pencil.
It's right here.
Oh, for real?
Wow. All right. Or you might see directly proportional to.
Can I write a word?
I want you to write the stuff on your notes first.
Okay, but when you're about to do it, can I write?
Once you get caught up.
Alright, look.
So again, when you see directly proportional to, that means we're going to be using this equation up here. This is going to be our home base for all these problems.
Home base. Hurry up. I'm making you start his work.
Alright, so again, k is your constant of variation. These problems will ask you what is the constant of variation. You look to see what number is directly in front of x, and you give that as your answer. How does this look similar to what we've been doing in times past? What we've been doing the last couple classes? We've been using this before, right? Y equals mx plus b.
There's an X and a Y.
There is an x and a y. And in fact, if we look at our homework, I think we have one that was like this. Number 7, you see your equation here says y equals negative 4/3 x. Doesn't that look similar to my equation, y equals kx? Where k is just your number in front of your x?
What is the thing say?
He has no property. Get it? He has no property because he's poor, but instead of coffee, he has tea. He has no property. Haha, property. Alright, so this is similar to our y equals mx plus b equation. We'll talk about that a little bit more here in a second. Alright, so our first problem here. Find the constant of variation. Joe, what is my constant of variation for this first one? Good, 3. K is my constant of variation. K is 3. Trey, how did I know that 3 was my constant of variation?
It was in front of the X.
Very good. It's whatever number is in front of my x. You're doing great. Alright, any volunteers for number 2?
What did I do?
Naman, what's my constant variation? Negative 1/2. Good. Make sure you keep that negative with it.
Good job, Nana.
Never Michelle called him.
You know he's always French.
Alright, number 3. Any volunteers? Yvonne? Very good. Negative 4. My constant of variation is negative 4. Alright, questions on that?
I don't know.
Okay, good. Hey, Sean, put away that phone. Okay. Alright, and again, we talked about similarities with slope-intercept form.
It's my turn.
I haven't called you up yet.
Wait, what's my name?
Alright, doing... I said hold your horses.
Oh, how do you say my name?
You want?
Oh, you just go.
Hey, it works. You're sneaky. Alright, so it says, do we notice any similarities to slope-intercept form?
There's a comb in your hair.
We just talked about this. The answer is yes. Alright, yes or no?
Yeah, you can't see it.
Why you have a comb in your hair? Take it out.
Because it's stylish.
I thought she was about to say it's stuck. I was like,
Alright, so in our slope-intercept form, let me borrow it momentarily. Slope-intercept form is y equals
that's green.
mx plus b.
You didn't even put it back in.
And in my equation here, when I have y equals mx plus b, if I did not have a number there, for example, y equals 2/3 x, what was my y-intercept for that?
What? No,
0, right? So my slope-intercept for my constant of variation, my direct variation here, my slope-intercept is 0. So b is 0. And my slope is just my k value. So m is just my k value. Okay.
M just is K.
Yep.
GK.
Alright, so again, my slope is my k value, or my k value is my slope. And my slope-intercept for these is always 0. Alright, I'll let you do one more. Alright, if m equals k, and then I'm going to do the next one. Yes. I want to see, and then write down what you just did.
Try to take the erase.
You didn't. You just messed it up.
All to the left.
Why do I get yelled at?
I just had to say your name because you were complaining about getting your name called out for talking, so. Figured I'd go ahead and say your name. I didn't even yell at you, I just said your name.
Talking?
How?
I wonder how. Stop talking.
How?
Alright,
What?
so if slope is just k, does anyone remember what my slope formula is? Good, my slope formula is y. Let me erase
What
this.
is that?
Y2 it's y2 minus y1, so I'm subtracting my y values, divided by x2 minus x1. So if my slope, m is just k, and slope is my formula here, but we know that my slope is k and my y-intercept is 0 for all of my direct variations, then k is y minus 0. Gentlemen, you writing this down?
Yeah.
Divided by x minus 0. And what's y minus 0? Y. And what's x minus 0? So that k is just y divided by x. Right, so very directly is when we don't have a y-intercept, or we have one, but it's at 0, 0. So that means one of my points is 0, 0, which is what we put in here. And so then my equation is just k equals y over x. Which if I multiply by x on both sides, I get y equals k times x. And that's where my equation comes from. That's where direct variation comes from.
Wait, so the y, wait, I had to make, cause before everything, you were all putting the k equals, so how is it y equals k?
So when I have k equals y over x, if I multiply by x on both sides, my x's cancel, so I have just y. And then x times k is the same thing as k times x. 2 times 3 is 3 times 2.
Remember when we
So then everything right over there.
remember when we say solve for y, that's all you're doing is just solving for y.
I think we might have even had you guys solve for y with this in a literal equation earlier.
Yeah,
They just
we
did
did.
it. Yes.
When is the T0 stuff for?
I was putting dots there. I was pointing out our point was 0, 0. Okay, so let's see how we actually use this. You don't have to remember why this is all true, but I want you to see how I wanted to show you why it was all true, and then now let's go and use it. Alright, it says x and y varies directly. Here's our key phrase. Varies directly. Anytime you see that phrase varies directly, that means we're going to have this. Y equals k times x. If it said that t and u vary directly, then we would have t and u up here. If it said r and s vary directly, we'd have r and s. We use whatever variables they give us. Alright, write an equation that relates to y. So when it says write the equation, let's go ahead and start off with our original. Y equals k times x. And you don't need to put that down in there to remind you that it's multiplication. Now they give us some numbers. What do you think we're going to do with those numbers? Put them in, yeah. So y is 12, so I put in 12 for y. Do they give me a k? No, we're trying to find that. K is my constant of variation. What am I going to do with x equals 4?
Put in 4.
Yeah, and we're multiplying here. And they even give us a hint. Find k, then write the equation. So how do I solve for k here? Divide by 4. Hey, Sean, what is 12 divided by 4?
3. That's 4 times 3 is 12.
K equals 3.
So I have that k is 3. Alright, now that I have my constant of variation, I can put that into my equation. Just like before when I was trying to write the equation for a line, I needed to have my slope before I could put it into my equation. So now I go ahead and write out my equation with my constant of variation. Y equals k times x. Well, I know k now. Y equals 3 times x. Since they asked for the equation, right, the equation that relates to y, then I want my final answer to be the equation. I wasn't just solving for k, I need the equation, but I had to solve for k to find my equation.
I think you should put y equals 3.
Because it said, write an equation that relates to y. So I need an equation with y equals.
Oh,
I needed to find k before I could write my equation. But I need to do more than just solve for k. Alright, so number 5. Again, it says varies directly. We start off y equals kx. What is my y value? Abdul, what do you think I'm going to do with that 4? Put it in for y. What is my x value? 18. We're multiplying by 18. Make sure you put parentheses around there. Alright. Mohammed, do you have an idea of what we'll do next to solve for k? Yes. I want to get k by itself. Yeah, divide by 18.
Keyboard.
18 divided by 18 is just 1. In tray.
Yeah.
You have your calculator in front of you.
I do.
Will you put in 4 divided by 18 for
I
us?
thought you said we didn't need it.
We didn't need it on that
4
one.
divided by 18.
One turn into a fraction. 2/9.
Very good. It reduces down to 2/9. Alright, so k is 2/9. But the instructions say write an equation. So we're not done yet. We need to write our equation. What's my k value? 2/9. And there's your answer.
Oh.
So again, make sure you read the instructions so you know what they're asking for. Here it said write the equation.
Is that a 10 or 18?
It's difficult if you.
Did you go to calligraphy camp?
No.
Psych.
Such a
Who has it?
Alright, we're gonna go and move on to the next problem on the back.
Wait.
Okay, you gotta stick with it.
Wait. Okay, go.
Alright, it says assume the variables vary directly. Again, we see varies directly. What's my equation when it varies directly? How? Good. Y equals k times x. I must start with that equation when it varies directly. Alright, and then it says use an equation to find the value of x. So now they're not asking for the equation, they're asking us to find x. But we need to first find our equation before we can do that. So this is a two-part problem here. First, I need to write my equation with this information. When we're done with this.
Yo, always need to use glasses. Yo.
Alright, so again, I need to first write my equation using this information.
Always need to
So
use
y equals k times x. I need to put in my x value, my y value. Y is 8. X is 4.
Wait, hold on.
Alright, when we divide by 4, what do we get for k?
Hold on. Let me get this.
What is k?
8 divided by 4.
Good, k is 2.
This marker. Where's the 4 from? What? The 4.
From x equals 4.
Oh.
You're so.
Alright, so we have our k value. We need to write out our equation. Y equals 2 times x. Doesn't matter. Alright, so we have y equals 2 times x. Now they asked us not to just write an equation, they want us to find the value of x. For this problem, this was actually typo, so I want you to change this.
It's not 8?
Nope.
What is it?
Let's change it to, pick a number.
3. 6.
Alright, let's go to 6. So change it says y equals 6. No.
Oh, that's denim.
Alright, so now we have our y value, we have our k value, we need to find x. So this is my next piece. I start off with my equation. In Q1, what's my y value?
6.
So I take 6 and substitute it in. And Trey, how do I solve for x?
Divided.
Divide by 2. Abdul, what is my answer for x?
Equals.
Very good. X is 3. Again, the question asked for us to find the value of x, so this is my final answer.
Yes.
So I have x equals 3. Alright, questions on that one?
What's today? 13.
Friday the 13th. Actually.
Okay, we'll do one more, then we'll move on. Alright, again, this is a two-part problem. My first part, I need to find my equation with that first chunk of information they give me. Y equals k times x. X is -2. Y is 14. I substituted my numbers that I have. Guys, come on, we're in the next one. Divide by -2. What is 14 divided by -2? Very good, -7. That's always your starting point, so you want to start off by writing that.
Which, when you know it's not that, why you gotta do it? Yeah.
That's your starting point.
But everybody knows that.
That really is your starting point. Alright, once we have k is -7, we can write our equation. Y equals, we now know k is -7.
should be putting the extra lines up in there to look cool. I used to.
Yeah.
What?
When I don't feel like looking cool, I leave it off. But I want to look cool every day, so I put it there.
When you want to look cool, time out.
No. We don't have time.
Time out.
All right, so then we need to do the next part of our equation. What? That is true, actually.
Oh yeah. I used to do it like.
Much better.
Swag.
Swag. Okay.
She's the coolest now.
All right, so the next part then, did it ask us to find the equation?
Cool.
No, we want to find the value of x. So let's use our equation.
Good idea.
Y equals negative 7x. And they gave us y is 21. We have to substitute that in.
It's not me. It's not for real. I might not have moved. So after this, we gotta do homework too.
We got a lot to do. That's why you guys gotta stop just
Someone should
interrupting
bladder.
things so we can keep going.
That's why I know with more homework than any of our other classes because we don't finish classwork in this class.
Good job, guys.
All right, 21 divided by negative 7.
Wow.
Very good. Negative 3. Are we done? Yes. It asks for x equals. We have x equals. All right, questions on 7 or 8? All right, now these problems should be super easy for you because we've been doing graphing for the last 3 days, and now we're just going to graph these again. Remember, this is similar to y equals mx plus b.
Bird.
For number 9, what is my y-intercept here?
Ow!
Yes, my y-intercept is 0. Did you catch that?
0?
My y-intercept is 0.
I already said that and you didn't say nothing.
No, I was making sure you were listening. Okay. Alright, so I want to go ahead and plot my y-intercept of 0 at the origin.
Oh, you wanted me to do that.
I want.
Oh. Are you calling me out?
Something wrong with you.
Alright, my slope is negative 3.
Thank you.
Joe, please pick up the pencil and bring it back. It's a cute one. I do not talk.
Didn't even say anything.
Yes, you did. Yes, you did.
I was talking to Tayshawn.
No, it wasn't.
And then
Did we tell you you won't be talking to anyone?
they told the whole class and they said,
We do talk.
Alright, my slope is negative 3. That's the same thing as negative 3 over 1. Hey, Sean.
Tayshawn.
What does that mean I need to do with my slope?
You need to graph it.
And how do I graph it? What does negative 3 mean I do?
Oh, you go down.
Good, we go down 3 to the right 1. Down 3 to the right 1. Or I can think of this as positive 3 over negative 1. Which would mean I go up 3 to the left. Up 3 to the left. Connect those dots to create a nice line. It's not the right spot. And notice again, my y-intercept is at 0.
That's what she gets paid.
Alright, let's take a look at number 10.
Wait, hold on. I couldn't get the last point. The green one, because it's barely there. I can't even see it.
Alright, so we have y equals
We're
2x. I'm going to do this one in green. You guys have a separate box for it. Alright, Trey, for this one, what is my y-intercept?
2. Well, 0.
0, right? Again, my y-intercept is 0. So I'm going to start at the origin. And... darling, what's my slope? Very good. My slope is 2 over 1. So I go up 2 to the right 1. It's all positive. Up 2 to the right 1.
On the roof.
Or we can do both negatives because that cancels out to be positive. Down 2 to the left. Connect my dots. There's my direct variation.
The unknown.
Again, notice that it has a y-intercept of
You was the worst spot
0.
ever.
Yes, Q1.
B, you always gotta plot the one in the middle.
Yes, because my y-intercept for these is 0. 0.
Oh.
0.
Why?
Because it can.
Alright, let's do number 11. I'll do this one in red. Do you have a different box for it? This one should be pretty simple by now. What is my y-intercept? Y-intercept is 0. So again, my y-intercept is at 0. And Trey, what's my slope for this one? My slope? Good, my slope is 1/3. It's positive. So I rise 1, up 1, right 3. Up 1, right 3. Or again, I could make both negative, because that cancels out to be a positive. So down 1 to left 3. Down 1 to left 3. Connect these dots. Oh, make yours look better than mine. And again, notice it is centered at the origin because for all of my direct variations, my y-intercept is 0. Alright, questions on this? Alright, number 12 and number 13. These ones are definitely the trickier ones, so stick with me for these. These are the types of graphs, or the types of questions they have on the SOL. These are pulled, I think, either straight from the SOL or modified a little bit from it.
Hey.
Alright, so it says, click on the grid to plot the point you want to select. These are the types of instructions you'll have on your SOL, because as you know, it's on the computer. So you'll actually be clicking on the grid. Obviously here we're just going to be plotting the point. It says the graph of the equation representing the direct variation passes through point A. Locate one additional point that is on the graph of this equation. Alright guys, so this is actually super, super easy. Don't let the fact that there's a lot of information throw you off. First of all, we see the words direct variation. When I see direct variation, what is my equation? Y equals k times x. For all of my direct variations, what is my y-intercept? 0. So guess what? We plot our y-intercept at 0 and we're done. For all of my direct variations, my y-intercept is 0. All they asked us to do was locate one point that's on the graph. Well, since it's a direct variation, your y-intercept has to be on the graph. We're done. That's it. Yeah, so the same for 13.
I've been in the sun.
We have to do one more additional step for 13. Guys, this one's really important.
13?
Both of them.
13.
Alright, it says draw on the graph to plot 2 points. So now we have to plot 2 points. It says point A is an element of a direct variation. Again, what's my equation for direct variation? Y equals k times x.
Good job.
Plot 2 points, so we have to do 2 of them, that are on this direct variation.
Good job, Kevin.
Alright, again, what is my y-intercept for all direct variations? 0. My y-intercept is 0. Okay, so we have one of our points. How do you think we'll find another point? Yeah. We could draw a line and find another point, or we could even just find our slope. If I draw my line here, then I can figure out my slope, right? What's my slope here? Up 3. To the left, 1, 2, 3, 4. Is yours different?
Yeah.
Oh,
So,
okay, on your notes, A is actually right here. Is that right?
So,
art show. Let's go.
-4, 2. Okay, so this is where A is on yours. Alright, so let's try again.
Stop.
Okay, so again, my y-intercept is a point. So if I look at my slope here, up 2 over 1, 2, 3, 4. So I went up 2. I went left 4, so it's negative. If I draw my line, you see it's a negative slope.
Trio right.
Alright, so if my slope is 2 over -4, which is just -1/2,
times.
we can plot a whole bunch of other points. Let me use blue. So I know that this is a point on my graph, and then I can use my slope to pick any other point. Up 1 to the left 2, or I can go down 1 to the right 2, or over here. Any of these actually works for my answer. Now you only had to plot 2, so I would recommend you do your y-intercept and then use your slope to find one other point. But all we had to do was look at our slope there. Or as Norman said, we could draw a line to help us find those other 2 points. If you draw the line, make sure you clearly plot 2 points though, because it doesn't say to draw the line, it asks for 2 points. So I want you to actually plot those 2 points. Alright, so my equation for this is actually y equals, my slope is -1/2, so just -1/2x. So it's actually my direct variation. So those ones, even though they look like they're hard because there's a paragraph of instructions, they're not that bad. Plot your y-intercept and then find your slope to plot another point. Alright, questions on that? So again, my answer would be any of these points here. Alright, next side. We're almost done, guys. Alright, number 14 says 2 relationships are described. Just because there's words doesn't mean we should skip it. Relationship S, so our first one. Karen drove 100 miles in 4 hours, and then she drove 75 miles in 3 hours. The other relationship, Vernon cooked 12 hamburgers in 4 minutes, and then he cooked 18 hamburgers in 21 minutes. Maybe he was really hungry. Alright, which statement is true about these relationships? Alright, so again, we can do this a couple of different ways. One way we can do this is take a look at the plotted points on a graph, and if the y-intercept is at 0, and it has the same slope, then we know that it is a direct variation. Alright, we could also set up each one and see if we get the same k value. Because we want to know, is this a direct variation? Alright, remember, direct variation is y equals k times x. Alright, so Karen drove 100 miles in 4 hours. Alright, let's say that miles is my y value and hours is my x value. So if I put this into my equation, 100 equals k times 4. When I divide by 4, what is my k value? 25. Right? We know that's true for the first one. Let's see if that's true for the second one as well. Let's try it for the second one. Y equals k times x. Y is my miles, so y is 75. And 3 hours, that's my x value. So k times 3. When I divide by 3, what do I get for k? 25 again. Since it's the same value, I know that it's a direct variation. They vary, they change the same way, the same amount each time. So I know that this one is a direct variation. Now let's check to see about the other one. Alright, let's say say hamburgers is my y value and minutes is my x value. So the first one is y equals k times x. 12 hamburgers in 14 minutes. When I divide by 14. 12 divided by 14 reduces down to 6 over 7. Alright, so that's my first one. Let's see if the second one is the same. Alright, so again, hamburgers is my y value, minutes is my x value. Y equals k times x. 18 hamburgers in 21 minutes. When I divide both sides by 21, you put this in your calculator and reduce it, it again reduces down to 6 seconds.
Isn't it reduced like less something like on Walmart? Like food or something. Reduced. Not like produce.
Like a reduced price on it?
Oh, no, I don't know.
Think we're talking
I
about
thought they said
recycle.
Reduce, reuse, recycle?
that's what I said. Yeah.
You're minimizing it, you're simplifying it. Alright, so we know that this one is also direct variation. They have the same k value both times, it's a direct variation. Here they got the same k value both times, direct variation. So which answer choice is going to be correct? A, both are direct variations. Good. Alright, questions on that one? Let's see what we have left. Alright, let's take a look at 12 and 15. 12 is similar to number 15 there.
We didn't have enough homework before the class was over.
Oh, yeah, once we get through these notes, then I can hand it out.
Not like
Alright, so it says, is this a direct variation? If yes, give the constant a variation. Again, we have my constant, my direct variations, y equals k times x. So I want to see, is there the same relationship between each one? So I put 12 in for y, and 6 in for x. What do I get k is? What do I get for k? 2. If I flip, 6 times 2 is equal to 12. 7 times 2 is equal to 14. 8 times 2 is equal to 16. Since that works for every single one, then yes, it is a direct variation. And my constant of variation is k equals 2. That's all you have to do for those. Check to find your k value and see if it works for every single one. Alright, then the last one. In order for these to be a constant or direct variation, it needs to pass through my origin and be a straight line with the same slope each time. Here my slope is up 3 over 1, so k is 3 over 1, which is just...
I should not be tacky, guys. We're not done.
1 minute.
Alright,
You have 8 minutes left.
Alright, I'm going to go pass out your homework to you. Worksheet 14 is your homework. We will have a mini quiz over this next class, so make sure you come to class prepared with questions. If you need to see us after class for help,
This whole
we're available after school
Alright,
today.
dang, this is why we don't do homework.
Monday.
That's why nobody does their homework.
It's because grass.
oh, oh my gosh, she's smarter. You know what?
So much work.
You get it back for the last one.
Have a good day.
I thought I had something right. Hair.
Alright, let's go and finish up those other problems here. So let's go back to number 15 up top here. Now we have more than 115. Alright, so it says, in which table does y vary directly with x? And again, like I said for the problem right below it, what we want to take a look at is if it has the same relationship between x and y. If it has that same relationship, then we know it varies directly, and we can solve for our constant of variation. So it's very similar to these next problems here. Alright, so we want to look to see is whatever has the same relationship between x and y. So x for my first one, letter A. X is 1 and y is 1. So to get from 1 to 1, we can multiply by 1, or we might say we divide by 1. Alright, the next step, 2 and 1. We would have to multiply by 1/2 or divide by 2 in order to get 1. Since these are not the same relationship, I know that A is not going to be my answer. Alright, so let's take a look at letter B. 1 times 6 equals 6. Alright, let's see if it has the same relationship for the next row. And we're looking for direct variation that it has the same relationship of multiplying by the same number each time. I'll be multiplying by the same number each time. Because remember, varies directly is y equals k times x. It means we're multiplying by k. We're multiplying by that same number each time. Alright, 2 times 6 is indeed 12. And 3 times 6 is indeed 18. So it looks like B is going to be your answer. So I'm going to check the other ones though, just to verify we didn't make a mistake somewhere. Alright, so 1 times 9 gives me 9. But 2 times 9 does not give me 5. So I know that's not the same relationship, so that doesn't work. And then for D. 1 times 6 is indeed 6. But 2 times 6 is not 7, so I know that that doesn't work either. So it looks like B is indeed our correct answer. Again, we're looking at we're multiplying by the same number each time. Alright, so same idea with 13. -4 times what gives me -1? If you're not sure, go ahead and set up your equation. We're looking to see if it does indeed follow this equation here. Y equals k times x. Alright, y is -1, and x is -4. When I divide by -4, then I get k is 1/4. Alright, so I know I multiplied by 1/4 here. Alright, so let's see if that works for our other ones. -16 times 1/4 is indeed -4. -16 divided by 4 is indeed -4. So that works there. -40 times 1/4 is indeed -10. -40 divided by 4 is indeed -10. So now it works for each of those. So yes, it is a direct variation. And I found my k value to be 1/4. Alright, that's my constant of variation. My k value is my constant of variation. Again, direct variation means y equals k times x. Alright, number 14. 15 times what equals 5? Well, we know 15 divided by 3 is 5. And dividing by a number is the same thing as multiplying by its fraction, its reciprocal. So 15 times 1/3 does indeed equal 5. Again, if you're not certain, then you can set up an equation. X is 15 and y is 5. So 5 equals k times 15. When we divide by 15, I get 1/3 equals k. Alright, let's see if this holds true for my other values. Because for it to be a direct variation, you must have that same k value each time. Right, 3 times 1/3, what does that give me? Well, that gives me 1, which is not 26. So I know it doesn't work for that one, so I immediately know right away that no, it is not a direct variation. Thus, we don't have a constant variation because it's not a direct variation. So number 14 is no. Alright, let's take a look at these last ones here. Again, in order for it to be a direct variation, y equals k times x, we know that because this is similar to my slope-intercept form, mx plus b, that my y-intercept is plus 0. That means it must go through the origin in order for it to have a y-intercept. Or in order for it to be direct variation, a y-intercept of 0. It must go through the origin in order for my y-intercept to be 0, and thus a direct variation. For number 15 here, it goes through the origin, and then we look to make sure that it does indeed have a slope of some value. Your slope needs to be either a whole number or a fraction, but it needs to be the same number each time. So here I look and I go up 3 over 1. Up 3 over 1. Up 3 over 1. You'll notice that whenever we have a line like this, that we end up having the same slope each time, because that's what makes it a line. Same slope each time makes it a line. Alright, so I know 15 is indeed a direct variation. And my k value is simply my slope. K is up 3 over 1, so 3 over 1, which is indeed 3. Alright, so let's take a look at number 16. First question, does it pass through the origin? Is my y-intercept 0? Well, here my y-intercept is -4, so I immediately know that no, this is not a direct variation. It has to go through the origin for it to be a direct variation. Again, my equation up here, y equals k times x, does not have a y-intercept. So it cannot have, or it has a y-intercept of 0, so it cannot have a different y-intercept in order for it to be a direct variation. Alright, and then number 17. Again, the first question is, does this have a y-intercept of 0? Now look, my y-intercept is -2. So again, immediately I know that no, this is not a direct variation. It must have a y-intercept of 0. Alright. I think there's one problem that we went ahead and skipped. Let's look back at that. Alright, number 6 here. Alright, one last one. X and y vary directly. If they vary directly, we have the equation y equals k times x. And it says write an equation that relates to y. Alright, they gave me x, which is 22. They gave me y, which is 11. Solve for k. So we divide by 22. We get 1/2 equals k. We're not done yet. It says write an equation, so I need to write my equation. Now that I have my k value, I can write out my direct variation equation. Y equals k times x, and k is 1/2 times x. And there's my answer there. Alright, I believe we've gotten through all the problems there. Remember again that your homework is worksheet 14, which is practicing these same concepts. If you are still struggling with material, make sure you come see us after school or before school or during stinger time so we can help you out. Make sure you're asking questions in class as well.